Hello, welcome back. Good mathematical morning. Um, I guess that's my thing now. I hope you guys are having a good day. You guys seem to blow through the assignment yesterday really easy. I hope that wasn't just because I gave the solutions. I hope you guys remembered all that stuff from algebra. If not, it is really important stuff, so please make sure that you understand that. We will continue to use those basics of algebra throughout the rest of the year. And when we get into our second unit, we will also do some more algebra, more in-depth algebraic properties and proofs and stuff like that as well. Okay. Also, we had our first live office hours yesterday from 11 o'clock to 12 o'clock. We might have stayed a little bit later than 12 o'clock yesterday, but for the first 20 minutes, it was just people were asking questions. There were about 20 people who joined us, and they asked questions, and I was able to go over a few concepts and some problems live, which was great. I think they found that to be helpful. And then after that was over, it just devolved into a social hour. So we will do our business first, and your questions will get answered. If you do have any questions, I strongly recommend attending those office hours. Okay, that'll give you a lot more interactivity. But if you guys are doing just fine just with the videos, don't feel like you have to join at all. And then if you want to hang out afterwards and just socialize and talk to your friends and show us your dog, and even if you don't want to show us your face, whatever, it's fine. Or you can show us your little brother's face. That works too. Anyway, so you can do whatever you want. All right, it'll be fun, and I'll see you guys at 11. So I'm actually looking forward to that. It was really good for me to be able to interact with my students. Okay, so let's go ahead and get started. So just a quick introduction. We're gonna finish out this unit this week, actually. So the last 3 days are gonna be over area. Friday, I think you're gonna enjoy it. We're gonna talk about Huron's method and Egyptian area, which is some more history of math, and it's totally advanced, totally really fun. I think you're gonna enjoy it. I'm gonna try to take kind of a simple, easy elementary topic like area and teach it a way that I can make it fun and interesting for me, and hopefully interesting for you, but also at the same time really easy. So the rest of this week you should just breeze through. Then on Monday we're going to take the practice test so we can see where we're at. Tuesday we'll review area and perimeter again, and we'll go over whatever you guys need from the practice test. And then next Wednesday we're going to finish this unit up with the test. Keep in mind you can turn in your homework. I want you guys doing your homework every day, but any homework, if you do get behind, if you don't turn any of your homework before Wednesday when we take the test, we're moved on to the next unit. So if it's not done by Wednesday, next Wednesday, you're not getting credit for it. It's going to go in for a 0. Okay. So, because when we move on to the next unit, I don't want you working on unit 1 stuff anymore. So please do stay caught up, and that's what we need to do anyway. Stay caught up on your assignments. Make sure you're doing them every day. If you can ideally watch the math video and try the assignment before 11 o'clock. So from 8 to 11, you got 3 hours to do it. And then if you are struggling, you can join for the live office hours at 11, and then you can finish your assignment or whatever you need to do in whatever time that you have. Okay, so let's go ahead and actually get started here. So we're going to talk about geometry, the basics again. So geo and metry, the geometry. The geo is referring to the earth, right? Like as in geography or geology. And then same thing with metria. That might look familiar. That's like metric system, and it means to measure. So geometry is a subject of math of measuring the earth, and one of the most basic ways that we measure the earth, and as we'll see how the Egyptians really developed a lot of their geometry, is because of their need to be able to calculate area of fields and of property in order to do property taxes. That goes straight to the pharaoh, right? So kind of cool. Math actually came about because of taxes. So when we are measuring the earth, there are multiple different dimensions we work in. So 1 dimension, which is just the length, 2 dimensions, which would be length and width, which would give us area, and 3 dimensions, which would add a 3rd dimension of depth, which would give us volume. So as you see here, like if this was 7 feet, this would be 1 foot out of 7 feet. Okay, that's our unit, would be 1 foot. And if we do 7 feet times 4 feet, so if we have like 7 feet of tile and then 4 feet of tile deep, how many tiles do we have altogether? Well, there would be area multiplication, and we just multiply 7 times 4, right? In that case, that would give us, I guess I could show it here, it would be 28 square feet, or feet squared. Over here we just have 7 feet, and notice there's a 1 here, an understood 1. That's because this is referring to the first dimension, the square is referring to the second dimension, and as you can imagine, over here we'd be having cubed, so 28 cubic feet, where each one of these is a cubic foot of 1 foot by 1 foot by 1 foot, length, width, and depth to it, and that would be 28 cubic feet, okay, because we'd be referring to volume. So we're going to focus on area today, and we're going to go back, way back. So do you remember these tables that you used to have like in 3rd grade on your desk, and it'd be taped, and you'd always pick at it during the lesson or whatever, you know. So your times tables, you remember that stuff? So really cool. If we were back in class, I would totally tape these on your desk just so you would give me a hard time, because anyway, so multiplication is area, or better said, area is multiplication. The two are one and the same. So why do we even do multiplication? Well, multiplication came about because of area. So let me give you an example. So these multiplications are actually, they're on the table themselves. So let me show you this one. This is 7 by 3. Okay, so we have 7 columns with 3 rows. So how many do we have all together? Well, let me see. I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm serious. 11. I lost count. I'll start over. 1, 2. I'm not going to start. You guys are going to like. I can hear you screaming at the screen. Just multiply it. 3 times 7 is 21, right? So what are we doing when we multiply? Well, if each one of these rows has 7 in it, we got 7 in the first row, we got 7 in the second row, and 7 in the third row. And if we add all 3 of those 3 7s together, or 7 3 times, that's where times comes from. What? So we have 7 3 times, and we add that together, which will give us a total of 21. Okay, so that is multiplication. By the way, we could do this the same way as well. So what do we have in each column? We have 3. 3, 3, 3, 3, 3, and 3. So how many 3s do we have? Well, we have 3 7 times, which will give us 21. Okay, so that's what multiplication is. And what's kind of cool is that those areas are actually shown right here. I'll do that and click the right button. The area is actually shown in the bottom right hand corner of our rectangle. Okay, so 3 times 7, the area is in the bottom right. Okay, so what if I did 7 times 3? So now I have 7 columns of width of 3 or whatever. And if you notice the bottom right hand corner, still 21. Yeah, so 21 here, 21 here. And if you fill this in to the bottom right hand corner, that's going to tell you what the area is. It was there the whole time. Isn't that awesome? Okay, so one more I want to show you. So I'm going to move this one out of the way if I can. Control 1. Yeah, I'm gonna move it out of the way. I'll go ahead and move this one out of the way too, if it'll let me. Shh, it's hiding. Don't wake it up. Then we have 6 and 5, right? So 6 times 5 is going to be 30, and we'll see the 30 right here. You'll also see 30 right there. Why is that? Well, because the entire table is symmetric, right? It's got a line of symmetry that's going diagonal here. So if we do 6 times 5, that's going to be the exact same thing as 5 times 6. So what we just demonstrated there is actually the commutative property of multiplication. So 5 times 6 is equal to 30, just as 6 times 5 is also equal to 30. So we can switch the order of our multiplication, across multiplication, and it's still going to give us the exact same answer. Just as if we take a rectangle that is a 3 by 7 and a rectangle that is a 7 by 3, they're both going to have the exact same area because it's the same rectangle, right? It's just the only difference is the orientation. One of them is vertical and one of them is horizontal, like, or landscape and portrait or something like that, however you want to think about it. So anyway, really cool stuff. I bet you never thought about that. I'm pretty sure your elementary teacher did explain that to you, that area is multiplication. You were just so young you didn't really retain it, or maybe I didn't retain it and I just figured it out. And it just makes me happy because math is awesome. Okay, so how many bundles of shingles? So we use area problems and area all the time for measuring anything in the earth, right? So if you're remodeling or putting in tile like I did, or you have to figure out your dimensions and figure out how many bundles of tile you have to buy, or how many squares, which is 3 bundles of of shingles that you'd have to buy to be able to roof it. All right, so they actually have something they call a square. So a square is going to be 100 square feet or 10 feet by 10 feet, and one square is, it takes 3 bundles of shingles in order to fill one square. So if we look here, we want to count how many squares we have. We got 1, 2, 3, 4, 5, 6, 7, 8, 9. I know, just multiply, right? So we have 3 times 3, which would give us 9. And over here, these look like thirds. Like if I took those and stacked them out, give me one more. So I got 10 altogether. So 10 times 3 would be 30 bundles. Okay, so 10 squares. But then on the other side, I got another 10 squares. So that would give us a total of 60 bundles of shingles. So there you go. Pretty cool, easy stuff that we can do. I don't know why the things showing differently. We also use area all the time whenever we're remodeling or we're doing tile. We need to know what's our width and what's our height, or however you want to look at it. So 12 feet times 20 feet, which would give us 240 square feet of tile. And we always get extra because we always end up breaking some, right? Over here we have 9 and 5. So 9 times 5 would give us 45. Or we could do 9 here. Let me push the right button. So we have 9, and then 9 more, and 9 more, and 9 more, and 9 more, and 9 more, 9 more, 9 more. And my handwriting just fell apart. That was an A. That's an E. Anyway, so 9 plus 9 plus 9 plus 9 plus 9 plus 9 plus 9. Oh, those are 5s. Those are supposed to be 5s. Wow, I need more sleep. 5 plus 5. Okay, I'm not going to do it. You get the idea. So 9 times is going to give us a total area of 45. I really hope you guys are watching this at more than just one speed, because otherwise, I know. I'm sorry. I'm going to try to be better. All right, so area of triangles. So this is kind of cool. Here we have a rectangle, and if I cut a diagonal across it, I cut the rectangle in half, and I end up forming a triangle. So in our triangle here, we can actually see that it is an equal half, because if I rotate this 180 degrees, it's exactly the same, right? That's kind of cool. All right, so whenever we are finding the area of one of the triangles, it's going to be half of the area of the rectangle. So if we have 6 and 4, this area would be, by the way, it needs to be separated by a right angle. That's pretty important. So 6 times 4 is going to be 24. So the area of the triangle is going to be 12, and the area of this triangle is also going to be 12. When we add those together, it's going to give us a total of 24. I'll show you another one. So now let's move, instead of just doing a diagonal, which is pretty easy to see that it's half of the square. Now see this point A, I moved it a little bit over, so it's no longer just a diagonal. But what's cool is it's still going to cut the triangle's area in half. See, so I move that. It's still, this is actually called a property of superposition. So in geometry, we can move things around in time and space, and they retain their properties. And that sounds so nerdy that I got that like memorized. Anyway, superposition, it's like geometry superpowers. Whatever, anyway, cool stuff. So I can move this piece over to the other side, and it's still the same piece. The area is still preserved. So this rhombus that we would have here, or parallelogram, is going to have the same exact area as the original rectangle that we did. Okay, just move it to the other side. And then I can show that they're the same by taking this one here and rotating it upside down. Perfectly upside down, and then moving it over here, and you'll see it matches up completely with the sum of those two parts, which is pretty cool. So the area of the triangle on the bottom is going to be 12, and these two parts together are going to be 12 as well. So we got 12 here, and then 12 is going to be the sum of what's left over as well. Okay, so if I move the value of A even further over, the same thing is going to happen. If I move it over there, that side's going to be the same as that side, and I can verify it by flipping this upside, flipping that upside down, which is close enough. You get the idea. Moving on. So area of triangles. The area of a triangle is half of the area of the rectangle, which is going to be the base times the height divided by 2. But you already knew that. I'm just showing you cool stuff. All right, so let's say we have this funky grid here. We got this house, and it's all crazy with all the gables and everything going on here. We need to find out how many squares we have, so how many bundles of shingles we need to order. So this is a square, 10 feet by 10 feet. So we got 1, 2, 3. Ooh, that's not a complete one. Uh-oh, what do we do? So there's 3 full ones and then a bunch of partials. Okay, I quit. I give up. No. So what we need to do is figure out how do we find the area of a parallelogram? So this is a parallelogram because this line is going to be parallel to that line. The top line is parallel to the bottom line. And so there is an easy way to calculate the area of a parallelogram, and let me show you why. So this was the area of our roof that's all partitioned out and kind of nasty. So the first thing I actually want to do is I'm going to take this part here and move it to that side. And then I'm going to take this part over here and move it to that side. And the lines don't match up perfectly because, well, let's be honest, this was three-dimensional with a partial depth to it. This face is closer to you than the back face. So it didn't work out perfectly, but you get the idea if I was able to draw it right. And then the next step, now I've got 4 complete squares. 1, 2, 3, 4. But now I want to take this partial, and I'm going to take the partial from the bottom. I know it's so cool. And move it up there. And so now you notice I have 8 complete squares all together. So 8 times 3 would give us, would it be 24? So 24 bundles of shingles that I would need to fill the front surface right here, which is kind of cool. So if I look at my math, there was an easy way to calculate that. So if I had 4 wide here, which I have 1, 2, 3, 4, so that would be 40. That's this green length here of our base. And then the height, which is 20, all you have to do is the base times the height. So 40 times 20 is going to give us 800, so which would be 8 squares. Remember, because a square is 100 square feet. So that is 8. So when we have the area of parallelogram, just take the base times the height. As long as they're separated by a right angle and it's perpendicular, you're good to go. All right, so then to find the rest, I've got this one back here, which is also 40 times 20, so another 8. And on the back side over here, way back there, I can probably draw a line so you can kind of see what I'm doing. So on the back side over here, we would also have 8. So we got 8 on the front, 8 on the back, and we got 8 right here, and 8 on the back side as well, okay? But you say, hey, this is not a full 8 on the front because this triangle got cut out, but that triangle got cut out, and it got placed over on the other side. Control Z that, push the right button. And it's this face, try it again. It's this face right here. Oh, it didn't quite work because 2-point perspective, drawing, art stuff, but you get the idea. So it is the same. So we have 8 on the front, 8 on the back, 8 on the front here. When we move that one back over there, and 8 on the back. So how many squares do we have all together? Well, that was yeah, so it's going to be 32 squares, then 32 times 3 would give us 96. So we would have 96 bundles that we'd have to get, and if there was 100 bundles that came in a pallet, we just order a whole pallet, and we'd have 4 left over. Probably need some extras, but anyway, you get the idea. Cool stuff. We just use area in the area of parallelograms and even triangles in a real-world example. When am I ever going to use this? I don't know. You want to do more than just flip burgers? Oh, so mean. All right, so area of hey, there's nothing wrong with flipping burgers. I worked at a grocery store for 4 years when I was in college, so there's nothing wrong with that. And now I teach math, which is so cool. So area of triangles, base times height divided by 2, because it's half the area. Remember, we can rotate that and it cuts it in half. Area of parallelograms is just going to be the base times the height. Now, if you notice, I've color-coded the bases and the heights. The height will always be perpendicular to the base. So if you want to know which one's the height, just look for the right angle. If you don't have a right angle, you can't do it. So look for the right angle, and whatever's perpendicular to that one will be your base. Okay. Another thing I need to point out is on the parallelogram, the bases are congruent. So this base here is the exact same as this base up here. So sometimes they'll give it on the wrong side, but we know this side is congruent to that side. Same thing with the left side and the right side when it's a parallelogram. Okay. All right, so that's it. Let's get right into the assignment. So pretty short lecture, not too bad. I thought it was fun, definitely going to be easy. And if it's going too slow, you can always speed it up with the playback speed in YouTube, which is kind of fun. So number 3, find the area of each parallelogram. So this is a parallelogram. We have our height here. We've identified it, not just because it's red, but we've identified it because it's our right angle. So the side that's going to be our base is not going to be the 9, because notice we're not drawing a right angle from there. We could measure a height from here. So if I drew a line across from here and then said it was perpendicular there, and I said this was some value, we'll call it x, we could calculate 9 times that value, but that's not what they've given us. They've given us 8 times 10, which is going to be our base times our height, so 10 times 8, which is going to be 80. So if I ask this question, it's always fun to ask this question, what would this value of x actually be? Now that we know the area is 80 yards, can we find out what this height would be if we dropped an altitude from this side of 9. So what it would end up being is it would be 9 times x, or just 9x, is equal to 80. So when we divide both sides by 9, this is so cool. 80 divided by 9, let me grab my calculator real quick. No problem. Thank you, TI, for extending our trials during all the COVID stuff to help out the teachers. That was very nice of them. So we're going to do 80 divided by 9, which will give us 8.8 repeating. So this value right here is going to be equal to 8.8 repeating, which is pretty cool. We were able to figure that out. And of course it has to be, because they have to have the same area. There's just more than one way to calculate it. Okay, so you don't need to know that. Don't worry about it. Main thing is, just look at whatever height they give you. Again, perpendicular, look for the right angle. That's our height. So the base is going to be the one that's perpendicular to it, which is this side over here. Well, they don't give us that side, but they give us the 8 on this side. So we can move it to over there, okay? Because the opposite sides are going to be congruent on a parallelogram. So we have a base of 8 times a height of 12. So 8 times 12, and then put that in the calculator, which gives you 96 millimeters squared. So pretty simple. Number 6, again, this one can be a little tricky because this measurement line here, the dotted lines are measurement lines. So that's not actually part of the parallelogram. It's just marking it off where it's parallel to it. Okay, so that would actually be the same. Let me actually move this in here real quick. It would give you the exact same thing as if they put it there. Do you see that? And in fact, if I do group it and then do horizontal, I can actually demonstrate that pretty easily. Don't you love the smartboard software? I am a huge fan. If I wasn't a teacher, I would be on their team. Anyway, so it's the same thing. It's just a measurement mark that extends it out there. So our height is going to be 2 meters. Okay. Wow. Learning just comes to life with this stuff. And so our base is going to be the top here, but that's going to be the same as the 7.5. Okay. So we're not measuring it off the 31. If we did, we'd have a measurement line coming out here and it would go all the way up to this line, but that's a mess because it's, crunched down. All right, so our base is 7.5, our height is 2, so that's just going to be 15 square meters. All right, so now we have a triangle, so we got to stop. What's different when we're calculating the area of a triangle? So remember, now it's the base times the height divided by 2, and you got your formulas there, so you should be fine. All right, so here, find your height. Okay, we got a lot of extraneous information. We don't need to know that this is 10. We don't need to know that this is 7.5. Because our area, our height, is not being drawn off of these values to the highest point on the opposite sides, okay? To do that, they'd have to do measurement marks, and it's just not how it's done, okay? So they went from the highest point, dropped the perpendicular here to give us our height, or our altitude. It's another word for it, by the way. The altitude of 6, think of like if this was a mountain, that's the altitude from the highest point down to the base. Yeah, it's kind of cool. So an altitude of 6, and then our base here is going to be 8 plus the 5. I'm going to have to add those two together, which is going to give me, it's not a T, it's a plus sign. It's going to be a total of 13 feet. So I'm going to do 13 times 6 divided by 2, okay, which put in the calculator, you get 39 square feet. All right, 14. So we got a right angle here. This is a right triangle. So these are the two legs of the right triangle. We won't use the hypotenuse because it's got to, the base and the height have to be adjacent to the right angle. Okay, so they have to include the right angle. So we're not going to use this 10.8. That is just totally extra information that we don't need. Okay, and I'm going to try to throw you extra information just to see if it works. Okay, all right, so 6 times 9 divided by 2. It doesn't matter which one's the base or which one's the height. You could easily flip the colors on that one, so it doesn't matter. Because the commutative property multiplication, it wouldn't matter anyway. So we get 27 yards squared. Is that correct? Yes, that is correct. All right, 17, backside. So this is a really fun number theory problem. I think you're going to enjoy it, especially because I'm going through it with you. So it says a triangle has an area of 18 square feet. List all the possible positive integers. So positive integers, that is symbolized by this little symbol here. Ooh, Z, this boldface Z is going to give us integers. I think the word for number in German, I don't know what it is. It's like Zeitger or something like that. Man, it sounds German to me, right? Zeitger. So anyway, that's the German word for a number. And so integers, they use the German Z for that, essentially a boldface Z. And we say it's a positive integer by putting the superface plus there. Man, that's like some high level math stuff. I just dropped that like knowledge bomb on you. You're welcome. That's what honors is all for. You guys get like the best of the best, right? Cool stuff. Anyway, so integers, positive integers, what that means is it's going to be whole numbers that are positive, so non-zero. So that would mean 1, 2, 3, 4, dot, dot, dot. Well, why didn't you just say that? Well, for mathematicians, when you say positive integers, that's what we think. Okay. All right, moving on. So I want positive integers solutions, so no decimals or anything like that. That's what they're really saying. And no negatives, because you can't have negative distances and area. That could represent the base and the height. So the first one is the first thing we want to do is we want to plug in what we know into our formula. So the area is 18. We know that we want to find the base and the height. Okay, so area is 18. And the first thing I want to do, base and height, I want to multiply both sides by 2. See if I can do that. Okay, so times 2 to get the base and the heights by itself. So when I do that, I have 36 is going to be, okay, 36 is going to be equal to the base times the height. Let me delete that. Okay, so I just multiply both sides by 2, not a big deal. So what I really want to know is what are two integers that I multiply to get to 36? It's kind of a cool way of solving this problem. That's really easy to think about, right? So the trivial one, meaning the most obvious one, when we just multiply something by 1, is 1 times 36 is going to be equal to 36. Well, what's another two factors of 36 is what we're doing? Well, about 2. 2 times 18, that would work, okay? So then we could do 3. 3 is a factor, so 3 times 12, okay? 4 is a factor, it could be 4 times 9. 5 is not a factor, just like fear is not a factor for you. Joe Rogan, it's funny. And then y'all probably don't even know fear factor, whatever. Dave Chappelle's funny guy. All right, so 6 and 6 is going to give us 36. That's where we're done. We know we're at the end. The reason we know we're at the end is I started with 1, right? And I went 1, 2, 3, 4, 5 didn't work, 6 worked, but 6 was exactly the start of the other side, right? So 6 is the turning point. It's also the square root of 36. Whoa, the number theory is just like blowing my mind right now. So any number that was greater than 6 would have to be tied with a number that is less than 6. So once we get to 6, we know we've reached the turning point. We're going back up on the other side, and we know that we're completely done. Oh my gosh, I'm going to have so much fun teaching you guys math this year. If you can't tell, I'm a huge nerd, and I love my job, and you guys are pretty cool too. So one day we'll be able to hang out in person again. But until then, come join my live stream, bro, at 11 o'clock tomorrow on Google Meets. It's not a live stream on YouTube. I'm not cool. Awkward silences. Okay, number 19. 18 similar to that. You can work on your own. It's kind of fun. Work on your factors. 19, the area of the triangle is 36 and the height is 9. We want to find the length of one of the bases. So I'm going to plug in what I know. Area is 36, height is 9. Multiplying both sides, we get 72 is 9. So the last thing I have to do, I don't know what, yeah, that was supposed to be hidden, but it's okay, is divide, which would give us 8. So the base in this case would have to be 8. So visually, what does it look like? Well, we have some base, we know the height is 9, and the area A is equal to 36. So I guess you could set up the problem like that. 36 meters, and then is it 01274? No, I gotta do alt code first. Alt 0178. Yeah. Oh my gosh, I need help. Anyway, so area is 36, base is unknown, and we have the height of 9. We can solve for the missing variable by setting up the equation using our formula and solving for the length of the base. So cool stuff. All right, number 20. Find the area for each different color. So this is color-coded with the logo. They give us the dimensions here. So it's kind of like we're reading a blueprint, which is kind of fun if you like engineering or architecture stuff. So we want to find the area that's painted blue. So that's going to be 4 times 8, which is going to give us a total. Let me lock that in place. Command K. Yeah, okay. Control K. And where are you at? 32 32 feet. So 4 times 8 is 32 square feet. For the red, the red's gonna be the triangles. We're assuming these are right triangles and they're isosceles. So if this is 4, this is 4. It's an assumption. Again, they don't tell it to us. but we actually could see it. Okay, so if this length on the bottom here is 14 and this is 10, that means the remaining part is 4. So it's 4 and 4. We're going to assume it's a right triangle. And we're assuming the same thing's happening up on the top, okay, because it is a parallelogram. So 4 times 4 is 16, but then remember we have to divide it by 2 because it's a triangle. So half of that would be 8, but then there's 2 of them anyway, so the total area is going to be 16 square feet. Okay, then the last one is such a weird way of doing this, is the parallelogram. So the parallelogram is going to have a total width of 14. The height here is the same as this height here. Again, they're just kind of showing it. Let me group that. Command. Yeah, so they're basically just drawing it out here, but it's exactly the same length here. They just move it out here to the measurement marks so it's not too crowded in there. That's all they were doing. So we have 14 times 8, which is going to be 7 times 16. I don't know, I'll just put it in the calculator. All right, so 14 times 8 is going to be 112. But then remember, we're not painting the blue part twice, so we're going to subtract the area of 32 from that. So that value minus 32, which is going to give us 80. So we're painting the yellow part. We're going to need 80 square feet of paint for that. There we go, 80 square feet. So what a fun problem. All right, 22. So here we have a triangle. What's actually kind of fun about this one, let me see if I can duplicate this. All right, so what's fun about this one is we have a triangle. Do you see the triangle? There's actually one triangle there. It's so cool. Okay, so if the base is 14 and the height is 14, what's the area of this triangle here? And I'm gonna shade it in here so you can kind of see. I said I'm gonna shade it in. That was terrible shading. All right, anyway, so 14 times 14 divided by 2. Do that. I'm already 30 minutes in. I'm sorry, guys. So I'll just do 14 times 7. But I'm working problems on the homework, so this is helping you guys out. Is 98. So if this area here is 98, then we know the area of the remaining part of the triangle also has to be equal to 98. What a fun problem. So anyway, you could basically, or you can move this part, move it to the other side and make a normal triangle out of it. But essentially we have a base times the height of 14, and because it's all in the same thing, it actually works out pretty well. So we can use our formula. 9 times 6. I think I forgot to update that. Yeah, so that should totally be 14. 14 times 14 as well. And then we divide that by 2, which means the answer is probably off. Yeah, that's not the right answer because I forgot to update it. But anyway, it's 14 times 14 divided by 2, or in other words, 14 times 7, which is 98. All right, moving on. So the last problem is here. You're going to solve for the area by deconstruction. So you're going to deconstruct this composite. This is actually a trapezoid, but we're going to deconstruct it into 2 different shapes that we know. So we have our triangle here, and then we have our parallelogram. We know it's a parallelogram because these little triangles tell us that these are parallel marks, like congruency marks, little triangles. So this one triangle, this one triangle tells these 2 lines are parallel, and the 2 goes with the 2, tells us that those 2 are parallel as well. So if this side is 10 on the top, it means this part here is 10 as well. So we have 10 plus the 14 on the bottom, which is going to give us a total of 24 inches for our overall base. And then we want to find our height. So I'm going to break this into 2 parts. So I'm going to do our parallelogram first. So 10 times the height of 10 is going to be 100. So this is going to be 100 inches squared. And then I want to find the triangle, which is also going to have a height of 10, right? If I move that over there, it's the same 10. So 10 times 14 divided by 2 is going to be 70. So this is going to be an area of 70 inches squared. It's terrible in. And then we can add them together, which is going to give us a total of 170 inches squared. All right, 24. This one is a little challenging, so we're definitely going to do it together. I got a triangle-ish and then a rectangle. The easiest way to break this one down is to extend one of the lines here, just like that. Okay, so now I got my rectangle on the right and the triangle on the left. So yeah, you can be a little creative on how you want to do these. And it's kind of fun. So how do I figure out this is 10? Well, if the whole height here is 16 and this is 6, then what's left over, 16 minus 6 is going to be 10. All right, now we can solve. Another thing I'm going to want to do is on the bottom here, I'm going to want to fix that. So the whole thing was 14. We got 5 on the top. So if I take away 5 from the 14, that's going to give us this side here which is 9 meters. So for the triangle, we have 9 times 10, which is going to be 45 when I divide it by 2. So 45 meters squared. And then 5 times 16, same thing as 10 times 8, because math is going to be 80 meters squared. So 80 plus 45 is going to give me, I believe, 125 meters squared. And there you go. I think I'm done. Yes, I'm done. Okay, so just under 34 minutes. I'm sorry, I had a lot of fun. I hope it wasn't as difficult to watch and not as painful, because you can see my enthusiasm, and when I'm happy, it means you're happy, because that's how math works. And anyway, so I enjoyed making this video. I hope you guys enjoyed watching it as much as I enjoyed making it. If you guys have any questions, of course, I'll post the solutions. Probably not solutions for the whole thing. I want you to do part of the assignment on your own. And you really shouldn't need all that much help, but I'll post the solutions for the more difficult problems. And if you're struggling, you can always join us at 11 to ask your questions. I can do the live tutoring, and then afterwards we'll hang out and just socialize. So see you guys. Have a good day.